So what I've done is I've done a flowchart which I am hoping
Mamma mia!
works.
Here we go again. OSK, read my message.
It looks reasonably sensible, John. That's just implementing it in code's still going to be a bit tricky. But you have got a flow to follow now, so it should avoid the spaghetti.
Yeah.
What I've done is I've just gone through the collision area and then just tested things and set flags. So there's no spaghetti, it falls all the way through and then sets flags as it falls. And then at the end, just check what flags are set.
Well, this is
starting with, are you dead?
Yeah. Well, this is if you know if you've looked at the flowchart, that's essentially what's going to happen. But we're going to have a couple of flags that allows the movement. So in the execution part, we'll look at the flags whether we can move or not. You still haven't seen my message. Hang on. What message? What message did I miss? We need to make a clip. A clip of what? What message have I missed, mate? The lazy pig shave. Really? What, the haircut? What do you mean haircut? Nothing wrong with my hair. It was a lot shorter than this at the weekend.
You can't do a proper program without ponytail. I'm sorry, it's like union rules.
Look, no, I'm not going to say it. No. Last time I had a ponytail was in my 20s. No. Not doing that again. There's nothing wrong. The only problem with my hair, it's grey. But I refuse to dye it because waste of money. I'm a Yorkshireman. Why pay money to make my hair go black when I can use boot polish or something like
that? Or just have grey hair.
Just have grey hair, yeah. You call it highlights. But did you fix the flowchart for the conveyor? Right, hang on. I saw your comment and I was... Because there's two parts to this flowchart. One where we're walking, yeah? One where we're walking, and then the second part is to handle the jump cycle, yeah? So, the conveyor... I don't get what the problem is, because the conveyor forces the direction, yeah? And the direction is based on the user input, yeah?
Right, but there's an issue, right? So
Right.
if you jump
The
through...
thing with the conveyors, if for argument's sake it's going to the right and you jump to the left and you keep moving left, you will keep moving left when you land on it until you let go of the direction, and then you'll be forced to the right.
Yes.
I thought you stood still if you moved against the flow of it.
Only if
You keep moving in the direction that you were walking until you let go of the direction,
Right.
and then you go in the direction of the conveyor.
Right, okay. Let me put this down. Right, 20 minutes. I'll say it's 20 minutes when we start, because we started talking for a while. 20 minutes. I won't do the clipboard thing. Right, so, okay. I see what you're getting on at.
This is probably a bad one to try it on, because you're going to be jumping in the same direction as the conveyor. You might want to go to screen 2.
Okay. Now let's find one with where I can get the conveyor easy.
I think that won't do
Level
it.
2 was perfect because you can jump on the one that was going to the right.
Which one? 2?
Yeah.
Yeah, level 2 there's a conveyor that goes to the right.
Okay, let's go back to level 2 then.
There's a table in the code that tells you what direction all the conveyors go.
Yeah.
Because it's only one conveyor per level, I think.
Yeah. Right, so that carried on.
That's not a conveyor.
Yeah.
Oh, I'm behind you, sorry.
Right. I see what you mean. Yeah, I see what you mean. But, right? But, then the test is, are we still moving? The test is, are we still moving here? In this force direction, we need another thing in there that says, are we still moving? Because you don't walk onto a conveyor, yeah? There's nowhere where
The test in the flowchart there was, are you jumping? And
Yes.
then it was, is there a conveyor that you're landing on? And in that instance, you will be jumping in the direction and holding the direction.
You basically need a flag. You basically need a flag that says, "Have you stopped on the conveyor?" You'll never walk onto one. You'll only jump onto them or fall onto them.
Okay. But it's
on level 7 you can walk onto the conveyor because you can stand on the wall on top of the exit.
hang on. 6, 7. Well, that was 7. Oh, that one there.
Next one is it. That one there, you can stand on that wall and then walk onto the conveyor.
Oh, going backwards. Yeah, you can.
Not as though you'd have time to stand on that wall with that thing there.
Right, hang on.
Well, if you pull the switch, it goes further away, so you might be able to.
Yeah, right, okay. So I had my finger going left, yeah? So he's heading left.
Yeah.
As soon as I press jump, I'm hitting the left button. Here we go. So that's doing them together. Right. So jump left. So he stays still when I've got it on left.
Yeah.
So that means it must be remembering his previous direction.
Yes.
Right. So if I can get him. Right. Let's see if we can do this. Jump. So it's I let go then. So it's remembering his previous direction. All right. So let's do.
Well, it's pushing in the direction of the conveyor.
Yeah, hang on. So I jump up and then he turns. But if I keep my finger on left, jump left, he stays still. Look.
Yeah, if you walk in the opposite direction of the conveyor, he will stand still unless you were already moving in that direction when you landed on it.
Yeah. So the walking. So it's not walking. It's not walking, or we would be able to walk across the conveyor in the wrong direction. And that's why he stops. That's why he stops dead when you're walking onto it.
Yeah, but if he starts walking onto it,
hang on, let's find
from the right hand side, and he's going left, he would have walked all the way across to the left.
Right, hang on. Let's
Start that version without sprite collision, John.
just about. That's what I was doing, mate. I was just about to see if there's a.
Is there something like level 11 got to be a long conveyor on the bottom?
I don't know.
I think level 16 might.
Oh, it's
16,
just unlimited lives, mate. There's not the sprite collision's not taken off. Okay. Well, this one will do. This one will do. Right, because we know. Right, we know that. Because he carries on, yeah? So, let's do.
He's cooking over that plan now, John.
Yeah, right. Here we
If
go.
you push right as soon as you jump on, it should stand still.
Here we go. So I'm going to jump back, yeah?
Yeah.
So it's remembering the direction of the jump, and then it carries on the walk, yeah?
As long as you keep pushing right, if you'd have jumped and then not held the key down, he would have walked backwards.
Hang on.
And
Yeah.
If you then press right, he stops.
But if I pressed right again, he would have stopped, yeah. Hang on.
Yeah.
Let's just prove. Ooh, that was.
So if you're in motion when you land on it, in a direction, then you keep going. But if you stop at any time, then you move with the conveyor belt, or you stand still if you're moving against it.
Yeah. So here we go. I'm going to jump. Yeah. Right. Now, I know that in the code there was a motion variable. There was
Yes.
a motion variable. And I think that is what the previous direction was. This H motion there, this H motion, because that's a global variable. So some of the in this logic here, before we even get to the collision stage, is working out whether what direction is going. So we've got the user direction there, and then we've got this forced direction, which I think is to do with the conveyors, and then we've got this H motion, which I think is motion from the previous iteration. Because here, right, hang on, could it be this? Here we go.
It's calculated just before there.
Yeah.
H motion is either
See, this confuses me.
right. Sorry. So it's force directions true or false. If it's true, then what?
Yeah, exactly. Right, I'm just going to copy it and I'm going to...
Yeah, if to break it down, it's like an if.
Yeah. So I've just made it into a comment so we can break it down. So basically it's going... That's the test, yeah? That's the test. And then it's true...
Yeah.
True...
Yeah,
that's it. True, false, which is there. Yeah.
So if it's true, it returns 2.
But it's not. It's another test look.
If it returns 0 if force direction is 2, otherwise it returns force direction, and if it's false, it returns the user key direction. That's
And
it.
I think this is what drives that entire motion, because I think 2 is where it's jumping. right? Hang on. Here, right? So this is the jumping cycle, yeah? And it's if the height is greater than -1, then it says, I think this is jumping. Because this is where we're not jumping and we start the jump. 655. What's 655?
And that's the line we were just looking at. So if he's jumping, then we return 0. Otherwise, you return. Right. If force direction is true.
Yeah, but the force direction, that is basically saying that true is equal to non-zero. Yeah? So any number equals true. Yeah? So any number means that this is any number will be true, but if it's 0, it's false.
Yeah. So if it's any number, it's true. So we do the first part. If it's set to a 2, then we return a 0 for H motion. Otherwise, we return whatever force direction currently is.
Yeah. So force direction. So force direction can either be -1, 0, 1, which is left, stop, right, and 2, which I think is jump. So this.
But just make a quick table, John, for H motion, and it's got 3 possible outcomes.
No, there's 4.
No, there's only 3 possible outcomes for H motion.
Oh, H motion. You mean this one here?
Yeah, for the next line, the 655 line or the copy of it.
Yeah. So
3 possible outcomes.
yeah, let's just do this motion. Because it was interesting that someone picked it out. So H motion will have outcomes of 0, which I think is stood still. -1, which equals going left. And 1, which equals going right. I think they are the possible outcomes. But I think...
No, it can also be force direction. Yeah, but force direction can be... Right, so
force direction is 1 or -1.
Force direction can be 2 as well. You've just seen that, yeah?
For the jump cycle, yes.
If it's 2, if force direction is 2, it returns 0.
Yes.
Otherwise, it returns whatever force direction is, -1 or 1. If force direction is false,
which means that
if it's 0,
0,
then it returns the user key direction.
Yes.
So if he stood still, it returns user key direction. Anything else returns -1 or 1 or 0 if you were jumping.
So in whoops. Right, so would be 0 would be when force direction equals 0, yeah? That's the only time it would be 0, isn't it?
No, it could be 0 if there's no user key input, as well as that being 0.
Yeah, but that's taken care of up here, look, because it defaults to 0 and then sets it depending on the key input, yeah?
Alright, okay. I haven't gone that far back.
So then if force direction is any other value, then it's force direction. Oh no, then it's testing the force direction. That's what gets me. its testing force direction is equal to 2. So if it's 2, then it returns 0. So
Yeah,
that
might just do your truth table based on force direction between being 2, 1, 0 or minus 1.
Yeah, that's what we need. So force direction equals 0, force direction equals 1, force direction equals minus 1, because I know that's the other one, and force direction equals 2. Come on, John, 2. Right.
So if it equals 2, we return a 0.
0.
If it equals 0, you return the user key direction.
Yeah, user key. So if it's 1, then we return force direction. If it's minus 1, we return force direction. If it's 2, we return 0.
Yep, that's it.
So the force direction is the direction that Wiele has to go, yeah? And the only time it's ever used is on the conveyor. That is the force direction. That's the only time force direction is instantiated. Hang on, let me do a search just to make sure that I'm right. There we go. Force direction here, conveyor. Force direction is equal to the direction of the conveyor off of the level. All right. So, and
then you handle it in the next bit where you go, if the output H motion that we've calculated from there is not the same as Wieele's direction, basically.
Yeah. So, yeah, so we know Wieele's direction because that's what was set on the previous cycle. So say he's going left, yeah? So if the new motion is not equal to the direction Wieele's going, then we come into here. So then we test, is the new motion that he's doing a jump, yeah? Then they set Wieele's direction for the jump, so basically it puts it into the jump cycle. Else they set it back to 0. Which confuses me, you know. You've just worked out his motion and then you're resetting it. But this is where force direction is set to 2. So force direction is equal to, is H motion a value? If it's a value, return the motion. If it's not a value, return 2. This is when we initiate in the jump cycle. Yeah? So it looks like they use the motion to jump forward and back, but if it stood still, we use 2 rather than 0. I think that's what it does. Because 0 means he stood still. So we can't really use 0, and that's why they've used this 2. So I think this is, the truth table doesn't govern this. Right? Doesn't govern this.
That bit's used to basically convert a 2 to a 0, so you can handle it as stood still.
Yes. Yes. So, and this is right. So is jump state equal to off? If it is, make the force direction equals to 2 and then set him to be going down. See, I think they've got off. Oh, I need to find out where these are. Enums game. I bet that's in data H, isn't it? Don't know. No. Ah, here we go. So they've got off, up and down. So they are. So he is doing up and down. Oh, that's where we're doing. Right. So if he's not going up, okay. So this is the up not going up, and so this means that. Hang on. This means where he's going down. Ah, yes, we're doing it there. Look, we're setting it to go down. Right. So that's what. So I've basically almost done the same thing. The only thing I've not done is put the flags in. I've not tested the flags. So this is where the conveyor belt comes in. Because if we're landing on a conveyor belt, because we don't walk onto... Well, I can't reproduce the walking onto a conveyor belt. But there was... I didn't test for the conveyor belt when I was just walking. Because we're walking, we're only testing for the wall. When we're walking, we're only testing for the walls. Hello, Wanderer. See, are we jumping? This is the thing. Are we jumping up? No, we're not. Is Willie jumping? Well, sort of, yeah, because we must be jumping down or something. Oh, I did this when I was... Do you know when you do something and then you start looking at it again and you're thinking, oh, I don't think I've done this right. Did I get your whisper? Yes, mate, I did. The only thing I will say, mate, is that... hang on. Let me... we're having a slight squirrel moment. Bear with me. Player sprite, here we go. No, it's not that. Am I in the right place? Yeah, Manic Miner. That one. Right. The only difference between the C64 version, I think that's what he was referencing, wasn't it? That's it. Hang on. Let me find your whisper. Let's just say, just watching, blah, 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 the original. The large step is the last. Yeah, but we've got the original Manic Miner only had 4 frames. We've now got 8. So the last frame is not the full width frame as you pointed out. See, if we look at the date here, let's get Monsignor Miner. So the second. So you were right. The final frame is where he's doing the wide stride. Yeah. But we've now, instead of 4 frames, we've got 8. Okay, but then you might want to rearrange it. The end result should be the same. Well, if I mean,
Hi, John here. Another subscriber. Stay a while. Stay forever.
Icon, thank you for the subscription. Show me you Willie. Stop it. Stop it. So, to rearrange these, basically, we're just going to put that in front of there, yeah? Because that will mean that the wide one is the end character, like you said, yeah? That's all we have to do. No, the first one is not the standing one. It's actually the half walking, which in our sprites is this one here. So that one could go into there, yeah? Yes, we would need to put that in front of that one. Like so.
The other thing with the sprites is that John's moving the sprite on every frame, whereas in the original Manic Miner, the sprite position on the screen doesn't change. The position of the sprite within its box moves.
Yes.
So the sprite walks across in a fixed position for 4 frames, then jumps to the next character and does 4 more animation frames that move them across.
Yes.
Which is why it doesn't matter.
Yes.
Yeah, I mean, I had it exactly the same as the original Manic Miner, but I just changed the first 2 frames.
Yes.
Well, because of the way John's doing it, mate, it doesn't matter. You can put 1,000 frames in, it doesn't matter.
No.
Because he's handling all that differently to how it was done in the original. So you'll notice...
No, I mean, it was only to make the walk cycle actually work, so that when it cycles, it actually works properly.
Yeah, no, I get it, mate, yeah. And it does. But if you look at the original game, if you put a ruler down the screen, when he touches that ruler, he'll always be in the same sprite animation frame because the frame is dependent on the 8-bit boundaries of the screen.
Yes.
So it's 16-bit boundaries of the screen because that's how he's done the whole game. The whole game works in 16-bit pixels. That's why that compression routine worked so well. Everything's in 2s.
I mean, that's why when he hits the wall, he's always in mid-stride.
Yeah. It's like Hands of Blue.
Yes. I noticed that when he hit the wall, he was always mid-stride, which is the last in the frame. And the only reason for that is because that is the furthest most sprite in the frame. So if we look at this one, right there, that's where he would hit the wall, which means he's got the stride on. But we're doing it differently because this works every 2 pixels. There's only 4 frames that he's having to cross 8 pixels with, because Manic Miner's 8 pixel wide, so that's 8 pixels he's got to traverse before he moves on to the next 2 characters, yeah? But we're not doing that because we're using sprite. So it may look slightly different, but the rearranging of the sprites is... I mean, we can rearrange it. I don't think it will make any difference, but let's do it. Save. So we'll save this as that, but we'll call it 4.2. And then we will export it. We'll just export the assets to Kick. And it is... I've got to have called it sprites. I must have called it sprites, yeah.
It's more like the PC versions, though, as opposed to the classic Manic Miner.
Yeah, right. Let's run it now and see what damage we've done. So it shouldn't make a lot of difference. Yeah, I think the only difference is his default character will be slightly walking. There we go. So he's slightly walking, look. So it doesn't make any difference. The only difference it's made is that where his initial start position is not stood still. Jumping seems to be the same. Right, so let's try and get this collision done. So gonna do this again. I'm gonna try and do it in bits this time. I'm not gonna try and do the whole thing in one go because I'm fed up of it. It got it my way in the end. It doesn't matter about the frames because we're doing it differently anyway. Right, so we're gonna do the walk. So the walking one is this. Now I take note of the input because we change where we're looking.
Evening, Mr. Kebab.
Say again.
So, good evening, Mr. Kebab.
Oh, he's in chit chat, is he?
He's in
Spy Hole. So let me find what I need to do. Right, so this is where we're getting the check. Right, I need to make these jumps. I need to make these jumps a bit more relevant. Right, so so we've still done this bit here. We've still done that bit there. Right, so let me just boost it so you guys can see what I'm talking about, and we'll try and get some of this stuff out of the way. There we go. Right. So we've checked how we're moving, and that's currently the user input. Maybe that is wrong. Maybe we should be having another variable called motion to determine are we moving from the last frame, not are we moving in this frame that the users decided. Hang on. They can wait. Work can wait. Let's do that so I don't get pestered. Right. So this place here is here, where I am testing if there's been some user direction. Now maybe that is wrong. Maybe the test for are we moving should be the last motion. Now I am not sure if I had anything for, see, I've got force direction. Maybe it's this direction.
How are you doing it? How are you doing it in the jump?
Say again.
How do you do it in the jump?
How do what, mate?
How do you know what direction it is when you're jumping? Because it's not, because if you wiggle the joystick in midair, it does nothing. So you're not testing the joystick at that point, are you?
So have a look at the execution.
So you must have done something that says if you jump in, this is the direction you go in. I would have thought.
That's probably in the execution. Hang on.
Can you reuse that? Because that's what I've done, I think.
Right. So Yeah, so loading direction. Oh, that's the final direction we're going in. Right, execute jump. Jump state. Jumping is only affecting the height. It's not affecting the direction.
Yeah, but when he jumps, but right or left, he goes right or left.
Yeah,
So how you...
that's covered by this, the direction.
Exactly. So can't you reuse the direction when you stood on the on the conveyor belt?
Yeah, but the direction is... Oh, direction is motion. Because Wiele.direction tells the execution system which way to go. So that is actually the motion. That's the end result, which is what they use motion for. Right. Okay.
Yeah.
Yeah. So instead of testing, but it means that we've got to evaluate the direction before we do the test.
Is it not set from the last frame?
Say again.
Is it not set from the last frame?
No, but we, like in this C program, he evaluates all the motion before he does all the collision detections.
Yeah, you can evaluate the motion, just don't act on it until later.
Yeah, because that's what the execution part is. That's the acting on the flags, yeah? So we can then evaluate the direction here and then do the because the direction is going to be evaluated based on the user input on what's happening. So we haven't implemented the forced conveyor system yet, but this is where the collision would be implementing the forced conveyor, the forced direction. So we need to implement this little subsystem, but this right, so I've got to work out what this is doing then, this if statement, because that's crucial. Let's see what we can do. Let's try and break it down. Let's do this. Let's do this. Right, that is... Right. So if not... Right. User key direction. I presume that's bitwise, Andy, yeah? This is what gets me. User direction will be 0, -1 or 1. And force direction and 2. What's evaluated first there? Because there's 3 tests here. 1, 2, 3.
The operators are all the same, so it'll work left to right. And there's no brackets. Plus, if it's a bitwise, it doesn't matter. Because it's an AND, isn't it? So all 3 must have the bits in the right place and the same place to get a 1. So it's completely irrelevant what order you do it in.
Yeah, and but this is this if statement's crucial for setting the motion. That's why I need to understand. If the user direction and force direction and 2 Hang on. C++.
Sorry. Double ampersand is just the same as and, I think.
Yeah, I'm gonna.
Whereas single ampersand is a bit wise, isn't it?
Yeah. Right. Let's see what we can do. So let's see if we can mimic it here. So int. No, let's not do that. Right. Okay. So.
Looks like it's just taking true or false.
0. Yeah. So 0 and 0 and 2. What does that give us?
That'll give you false.
Yeah.
So we shouldn't get this C out.
So it gives 0.
Yeah. So it didn't go through it. So this was false. Right. So if... Okay, let's say if the force direction is -2. Is that false?
Yeah, because you've got a false in there.
Yeah, because you've got 0.
I know.
Basically, they've all been on 0.
So this is basic... Right.
This is true false. 0's false, anything else is true.
Alright, so not equal to. So we've said force direction is -1 and user key is 0 is not equal to force direction, which is -1. Hey Proton, welcome in, mate. Thank you for the raid. Sorry, I've just seen it. We're just trying to figure out if statements. So that was going to be 0 because his false is not equal to true.
Yeah, you've got your first statement as a false, so you're never going to get a true. So
it's all
0 is a false, so that's always going to be false when user direction is 0.
So key direction is important for changing the motion. Somebody didn't like something.
Willow jumped on my knee. Jasmine didn't like it.
Right. So that worked. I need to change this, don't I? Hang on. Let me change this. Int user direction equals -1. Int. It's probably not int. I'll probably get thing. Force direction equals -1. And what's the other one? That's it, isn't it? It's just a 2. 1, 2. Yeah. Okay. Now that's not going to work. He's going to tell me there's something wrong with this.
Unsigned int.
Yeah. Or
Hey,
might allow it.
No, it will allow it. It's not unsigned, it's signed, so int's fine.
Yeah.
Yeah.
Right. So let's do that. Let's put that test in there. Right. So the test is not equal to user direction and force direction and 2 is not equal to force direction and user direction is not equal to force direction. God dear. Right. So if the user direction is 0 and the force direction is 0, we should not go in there. And we do. Right, so if there's no user direction and there's no force direction...
Yes, but you've got a not at the beginning, so the output's false, which makes it true.
Yeah, but I'm understanding why that not's there, yeah? So if we put a user direction but no force direction, then motion should be changed. Okay.
No, because you're handing one with 0, which is always going to be 0.
I'm just trying to understand where it would not do the change.
Well, they're both going to be true.
I wonder if it's that one.
Force direction 2.
No, still lets it go through. Because user direction would never be 2.
Yeah, but force direction is either 1 or -1. It's either going forwards or backwards.
Yeah, but it can be 2 as well, mate.
Well, it's 2 because it's 2 pixels that it's forcing you in. It's 2 or -2 then.
No, it was
No.
1
No.
and minus. Force directions. Or was it force direction that's 2 when you're jumping? Yeah, force direction is 2 when you're jumping, isn't
Yeah,
it?
it's 2 when you jump in, yeah. I don't understand this. I don't understand this if statement. So basically that's saying if a number and a number and a number, then that would be true.
What are the variables again?
User direction, force direction.
What's the third one?
What, the 2?
Yeah.
That's what it's set to. It says 2.
It's the wrong way around doing your compare, but it prevents you accidentally assigning something to a variable. So instead of doing if m force direction is not equals 2, you do if 2 is not equal m force direction. It's not a problem with that, but where you do if 2 equals m force direction, if you forget and put a single equals instead of a double equals, it throws an error.
Oh, is it the assignment, non-assignment thing?
Yeah, it stops you accidentally assigning 2 to force direction if you only put a single equals in an if
Which
statement.
wouldn't be a compiler issue.
I'm missing something here though. If we do that ampersand 2 as a constant.
No, it's not and 2, it's and 2 is not equal to force direction.
Okay, right.
John, make it more obvious. Put brackets around the 2 equal not equal force direction and round user direction not equal m for. So yeah. So you can see it as 4 separate statements: U direction, force direction, and brackets round user direction not equal force direction, and brackets round 2 is not equal force direction. So you can see the actual statement. No, it wants to be there and there, yeah, and also the 2 not equal.
So you think that this is the and with that, yeah? And you're saying 2 is not equal to that. But what about all this?
Yeah, put brackets around that bit. 2 not equals force direction should be in brackets. Just to visualise.
This guy shouldn't be allowed near a C compiler.
There you go. There are your 4 statements. User direction and force direction and 2 not equal force direction and user direction not equal force direction.
Really?
That's exactly the same statement. It's just brackets make it more visual.
God, dear. He overcomplicates things, doesn't he? So this
And you
is
could do it as four nested if statements, I suppose.
yeah. So
But
basically,
it's not, because it does a not on the whole result.
yeah. So
The thing
basically,
is, if you actually wrote decent or wrote readable C, it would help a lot. But it doesn't.
Tried to be clever and use fancy things like he's used tertiaries earlier on as well,
Yeah.
which work, and yeah, but they're not easily readable.
Then
So-
again, you haven't seen my code.
so we're adding that this is a number and this is a number, and whether this force direction is not equal to 2. Is that and in the user direction is not equal to force direction?
So if you set force direction to 1,
Right, let's split this up.
that gives a true, a true, a true. So,
So it's a 4 thingy truth table, isn't it?
it is, yeah.
Oh, there we go. So that's it. So that and the result of that and the result of that. Okay. All right, let's see if we can do this. So
Purely on a true or false basis.
yeah, and then the whole result is then inverted. All right, and so let's do this. So no user input, but the force direction is 2. That means it's jumping. Says motion should change. So that would satisfy that. So that would be true. That would be false. No, that would be true. No, that would be false. That would be false.
Yeah, but user direction is false anyway, so it's always going to outcome true.
Yes. So the only way that we can get a false out of this is for there to be a user interaction, that force direction has got a number, that force direction is not 2, so we'll call it -1, and that the user direction is not equal to, so that should come on. Right. So what's that telling us? That the user direction, if the user direction is different than the force direction, we're not going to update the motion. But if that's a 2, so what's that? So we update the motion. We update the motion if he's jumping.
I'm going to throw a spanner in the works and say if 4 dart equals -1, then there's no motion. Everything else is motion. Got to remember that those hands are doing logical operations. So all you need is one true value, a true outcome, and that whole and statement becomes motion should change. And the only one so far that you've got a return 0 on is when you've set the 4 dart to -1.
Yeah, but if I do that, That throws a spanner in your works, mate.
It doesn't. It doesn't. All it means then is it should be if for the. Sorry, let me think. Aye, if for the.
So
equals right. So if user the equals -1 or for the user, sorry, if user dar equals -1 or for dar equals -1, then return 0. Everything else motion should change.
That's what I'm trying to understand, mate. Is it that? Is it that? Because this is just saying, have I got a number? Yeah. Which is right. There is a number because it's -1. 4Dio's got a number because it's 1. So true. This would be true because it's not 2. And this is true because they are different. So therefore we don't update the change. As soon as I do that, it's gonna say that the motion's got to change because it's a jump. And I'm just trying to understand why the motion changes on a jump. Oh, I see. Oh, I see it now. I see it now. When force direction is 2, then we set H motion to be 0. I see it now. So on the jump, we are stopping. We are telling Wiele that he's stopping. That he's not actually is directionalless. Directionalless. Yeah, whatever.
So that still makes what I'm saying true, though, John, does it not?
That's what that's why I was trying to understand the if statement with the motion if statement, yeah. Because
yeah.
I was thinking surely this could be made a lot simpler, you know.
Yeah, you just need to check for -1s on both of them and job done.
Yeah. If you're being forced in a direction and the user tries to go the other way, they can't. If you're jumping, then they will still move, probably in the jump direction. Yeah. Yeah.
If you're jumping, you're already in
motion.
You've already got a motion direction, whether it's 0 or left or right, and you can't change that.
Yeah. Because that is, if force direction is a number, is it to set it to 0? That's all this is doing, isn't it? It's converting the 2 into a 0.
It's converting the 2 into a 0 and a 0 into whatever the user input is.
Yeah, that's all it's doing. It's because 0 means stood still.
Yeah, that whole thing can be replaced with if FD equals 0, then your output is user input. If it equals 2, it is 0, and anything else it equals what it equals.
Yeah. Oh, God, dear. Hey, Enfant, welcome. Oh, God.
But you only do it when they're opposite.
When force direction and user direction are opposite, yeah?
I think so, yeah, that's what 6502 was saying, isn't it?
Yeah.
If one's -1 and the other's +1, or vice versa.
So basically, if one's not the same as the other. So if force direction is 0, okay, force direction is 0 and user direction is 0. Oops. Let's just try that combination.
That whole thing would have been made much easier with booleans, wouldn't it?
Well, tell me about it, mate. Tell me about it. See, it says it should be motion. So if they're the same, it says it should be motionless. It should change.
That's exactly what I've done. It's in the status flags.
Yeah.
So I just mapped out the bit of the status flag as a boolean and worked it that way.
I mean, the only reason for using numbers, I would have had enums or constants against that to make it readable. It's just...
God.
I'll put some brackets in to make it readable.
Well, that as well, aye.
Right, so...
Its code is very hard to read.
Yeah, so the whole point of that if statement is to see if user direction is different than force direction. That's the whole point of that if statement. Why the hell did he just not do that?
John, you've seen the rest of his code.
Oh no! I know.
Some bits really good, but other bits are just ludicrous.
I know.
It's like he's written in C, but he's not a C developer. Like he's a Java developer or something, and he's or a C hashtag developer.
Right. He's watched lots of videos or read lots of things about how to do clever bits of code.
Yeah. I mean, his basic code's all right. His basic, overall it's okay. It works, but some bits are just... Well, I know I've not written C for 20, 30 years, maybe, but even so, it's better than that crap.
So it would have been a lot easier with a nested bunch of ifs would have been a lot easier to read.
Yeah. So...
But
Did Jeff Minter teach him to code in C then?
Oh, Jeff Minter's code's awful, mate. Don't get me started. And he's got a smelly sofa. And when we all meet up, I'll tell you why he's got a smelly sofa. And I'm not saying it on YouTube.
I'm not sure I want to know.
It's not as bad as you think.
Right. Okay. So, we need to evaluate the motion. We need to evaluate the motion before we even do... We need to evaluate the motion. I'll leave the stream to you guys. Go on, just carry on.
Sorry, John. Carry on.
So we need to evaluate the motion before we need to evaluate the collision. Yeah? Because the collision is based on the end result of the motion. Yes, it is. Is the motion plus or minus? So that's what we need to do. We need to evaluate the motion before anything else. So
Sorry, I got angry.
So, right. So in essence, if the user input is different from the forced direction, then we reevaluate the motion. That's essentially what we broke it down to, yeah? Are we in agreement on that?
I think so.
Yeah.
Yeah, so I had to mute you there. Yeah, I agree.
So, I've got the user input. The force direction I have got a placeholder for, if I look. Yeah, force direction. So I've got that, and I've got a motion. So here we go. So we can use this variable for the motion. So we've got the user input there. The direction. I'm just wondering if I need that now. Because motion is going to take over it, isn't it? Yeah. Now, I'm just wondering whether to keep direction and forget motion.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Oh, Stack Bats, thank you for the bits, mate. Thank you. Oh, I should still say biscuits, shouldn't I? That's still biscuits, isn't it? Yeah, bitsquits. Right then. Okay, so we will use direction because that is the final direction. So that's the direction that Willie's going to go. So we can forget motion. So we'll leave motion behind and we'll work on direction. So let's write the routine to work all this stuff out. Let's do it down here.
All bits donated tonight, by the way, are going to be going to the King. Just so you know.
Are they?
Yeah. When you get your customs bill.
Okay. Okie. Can't wait. Right, here we go. Right, let's put it here. Right, so work out direction. We'll call it that. Right, so load storage dot Wiele dot input direction, compare it with storage dot Wiele dot forced direction, and we were saying that we will update when they are different. So branch if not equal to work out direction. That's what we agreed, yeah. If they are the same, we just drop out. We will leave direction intact. Alright? So, now we're going to so then we need to do this stupid equation, yeah? Right, so first one is storage dot Wiele dot force direction. Right, if force direction has a number, right, so if it's hang on, I'm looking back at this. So we're doing this bit. So if force direction has a number, then it does this. But if it's 0, then it does the user direction. Okay. Yeah. Right. So if force direction is equal to 0, so we're going to say branch if not equal to evaluate forced direction. But if force direction is equal to 0, then we are going to take the user, so LDA storage dot Wiele dot u dot use, no it's not, it's input direction, and then store it in storage dot Wiele dot direction. RTS. So if force direction is equal to 0, we are taking what the user inputs and storing that in the direction. Alright? What does the plus do, by the way? If these the labels with exclamation marks at the beginning are classed as temporary labels, yep. And the plus means that you want to go forward to that label. See, you could have this. You could have this branch if not equal to that, and branch if equal to that. Yeah. So that's saying you want to branch backwards to the label that is only exclamation mark. So, for example, in code, we would have one there and say one there. Yeah. So this is a valid label. It's called a temporary label, and you don't have to name it. You just put it there. And what this is doing, it's saying branch if not equal to the temporary label going backwards. So it finds the first temporary label that matches that, which is this one. This one is saying look forward for that temporary label, which is here. So this would branch forward and this would branch back. Does that...
You can also have branch minus minus or jump back to labels. Yeah.
So we could do this. So what Sources just said is this, right? Say, because the temporary labels, you can have, and Proton is notorious for this.
It works, it just doesn't make it very readable because you don't know why you're doing.
But what happens here is if you put minus minus and say plus 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 like that, this would look for the second incident of that. So it would jump back to this one, and this one would look forward 3 iterations of that, which means it would jump forward to that one. Right?
It is an assembler thing, not a 6502 thing.
Yes, it's assembler related.
Yeah. And they're scoped by the curly brackets.
Yes.
So they're really valid with those curly brackets.
Yeah. And if you were using CBM Prog Studio, it would be like that. You would jump to an @ sign in CBM Prog Studio because Arthur implemented it as ats rather than exclamation marks. So I hope that helps. Little bit of education there.
The big advantage is you can use exclamation mark loop in every single subroutine you've got, and it'll always jump to the right one because it's scoped.
Yeah. Proton!
Just think of it.
Proton! He's notorious for it. When I look through Proton's code, I'm going, which one is it jumping back to?
Well, if it's scoped locally and you've got a loop for something, it's a lot easier than having to put loop that does this or loop that does that or loop 1, loop 2, loop 3, which historically before this, with just standard assembly, every label had to be unique.
Yeah.
So it's a damn useful command or feature.
Yeah, I see, but even me, I label the temporary variables anyway, so... yeah.
I don't mean leave them blank. I mean, it allows you to use like exclamation mark loop in every routine. Which is a big advantage.
I do use them rarely. I do use them rarely, especially in tiny loops. You know, they're fine. Yeah.
But just use exclamation mark on its own is a pain in the arse, and don't fucking do it, Proton. It's just you being lazy. Get a good keyboard.
I love Proton to bits, but he's a pain in the arse when it comes to trying to work out his code. Right. So back to this.
One last thing. It has no effect on the speed your code runs at. There's no excuse.
No.
Does it assemble quicker using temporaries?
Not on my M3 iMac now. But let's face it, modern PCs are that fast, it doesn't matter, does it?
I suppose
I would have thought so.
You're talking tenths of a second, hundredths of a second.
Yeah,
I'm going to change my code and see if it makes a difference.
it will.
You've got to watch out.
I suppose it would take more cycles to work it out, because it would, instead of it looking for a specific label, it'd have to count back the number of iterations to get it. But
stop using them, John. You're 70 now. You haven't got much time left.
Let's be face it, it'll save you probably. I mean, my code assembles in roughly 30 milliseconds. So the actual time you'd save is not really that much, is it?
No.
Each to the own.
Okay. You know to try it on your 286 though.
Do you know what, mate? I ain't anything that old. I gave it all away.
Oh, okay. Branch if equal to reset. Forced.
Actually, I'd love to. Oh no, Java won't run on a 8088, will it? Never mind.
No. Right. Okay, so. Oh, come on, John. Get a grip.
Java runs everywhere. What are you talking about?
Not an 8086, mate, it won't.
I'd love to see it. Taking a week just to load Java.
Right.
At least it crash quit.
Right, so back to the equation.
Search says it does.
Right, back to the equation. So we test force direction with 2, which is the jump. Yeah. And if it is 2, we're going to reset it. But if it's not 2, we're saying direction is equal to force direction. So we're resetting it to 0 when it is 2. I hope that works. So that evaluates the new direction. So if I get back to where we're doing all this jiggery, pokery, biddery, dibbery here. So here, right. So if I do it there, so that's going to work out the new direction. So we are now testing Wieele's direction, not the input. So we're going to be testing the new direction. The problem is, oh, is there a problem? Oh, I bet this is where these other two tests come in here. So if the motion... Right, so if we take that as... So is the motion not equal to the direction? Oh, that's confusing. What's direction?
I guess that's the direction he was currently moving in before you came around this loop.
Yeah, but it doesn't seem to be referenced anywhere. Oh. What am I doing? I'm searching my own thing, aren't I? I'm in the wrong search.
It feels like it should be previous direction.
Oh, here we go. So, oh right, okay. So we do need direction still and motion. Okay, let me go back. Let me go back and put that back in. So we definitely need. Let's reverse that change. Put motion back in there and go back in here. And we're not changing direction. We are going to be changing motion. Work out motion. Okay, right. Let's change that, and that. Right. Reset motion. Evaluate force direction. Work out direction. Well, work out motion. Right. Let's go back up here. So we work out the motion.
So are we now saying motion is the motion calculated for this frame and direction is the direction he was going in the previous frame, basically?
It looks like it, yeah.
You know, something, he was moving that way last time round. We now, the next loop, have we got an input? Are we forcing him to move, etc.?
Yeah, so if the motion is different to the, well, no. Yeah, the motion is different to the direction.
And it's true, which means it's got a -1 or a +1, not a 0.
Yeah. So this would not update if motion was 0, yeah?
Yeah. Yeah, that kind of makes sense. If it's not 0 and it's different,
Yeah.
then it's not different. Yeah.
So we're going to have to put that in before we. So we're going to be testing the new motion. So here we need to update the motion. So motion. Now, if it's equal to 0, branch if equal, then bypass, because we're not changing anything. But if it is equal to something, then we're going to compare it with storage.wiele.direction, and if they are the same, we're going to bypass.
Just a quick off-topic question, but still slightly on topic. Is there a long branch in 6.5 CO2, or is that not implemented?
No, it's called jump.
Okay.
I created some macros to do long branches.
No, it's just that I've been using it quite a bit with the 45 GSO2 on the Mega 65. It's a game changer.
Is it similar to what I've called these then? So jump if negative, jump if equal, jump if CS, jump if CAC.
No, so you just put an L in front of the branch of equal, so it's LBEQ, and it gives you a 16-bit jump.
Oh, right, okay. No, I created
the same as your macros, yeah.
Yeah,
Yeah.
I created macros. Okay, so right. So back to this. So if it's the same as the direction.
So basically, your 48GS thing is like a Z80. It can do long branches.
Yeah. So it saves you a line of code.
You're trying to copy a superior processor. Okay, carry on.
I hate the Z80, mate. You know I hate the Z80. It broke my poor 12-year-old brain.
Oh, dear. Right. Oh, that's not bypass, is it?
But at least I don't have to use VS Code to program it.
John's going to start doing Z80 now, aren't you, John?
I'm going to have a go at it. I'm going to have a go. I'm going to learn I'm going to try. I'm going to learn on stream. I'm not going to cheat and do any research. I'm going to learn on stream, so there's going to be a lot of boring streams coming. I have not got time to learn it off stream. I've got other things to do.
No comment.
It'll come back to me once you start using it. I'll be able to tell you all the best way to do it.
Right. Well, the first thing you do in Z80 is you get a tattoo, right? And that tattoo on your arm needs to say, "When I do a load, flags aren't set."
Correct.
Because that's the worst thing about Z80. It doesn't set the flags on a load. So you have to do a compare. It doesn't. If you do an
But it's
LDA...
also handy because sometimes you don't want to change the flags, but you need to change what's in a register.
I know, but when you've been in 6502 for so long, it's just like it does not compute.
Yeah, it's a different way of thinking, yeah.
And then you go back to 68,000, and 68,000 does set them.
But then you use things like XOR to set registers to values, which does set flags.
This is true. Right, I just remember Shallon's stream. I was constantly screaming in chat, flags, 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 flags.
Yeah, it's just a different mindset. You same as with 6502, you learn ways of doing things that work with that processor.
Slide 0 page. I'll put up now, let you crack on, mate.
Right, so this is this bit. That's that bit. And this one is motion is not equal to direction. And this one is motion is not equal to 2. Right, so once we've worked out the motion, then we look at the motion. If it's 0, we bypass, because we're not going to update anything. So that bypasses it to down here. If it's got in here, that means motion is a number. And so we compare it with the Wiele direction. If it's equal, then we reset motion. We reset motion. If it's equal to... oh, that goes through it as well. Yeah. So it resets. So it resets motion back to 0. So I presume that's ready for the next cycle. But if it's not equal, if the direction is not equal, well, hang on. Let's do this again. Branch if equal. If it's not equal to direction, then we test for 2. If it's not equal to 2, we're not going to do anything. But if it is equal to 2, we are going to store it in direction. But that can't be right. No, that can't be right.
No,
it needs to go there.
if it is equal to, yeah, not equal, it goes to there, yeah.
Because we need to reset it, don't we? If it's not equal to 2, do that, reset. Yeah, that's better. I was going to say, because all we're doing is converting 2 to 0, aren't we? If it's not equal to 2, store it in there. But if it is equal to 2, then motion is 0 because he stood still. Right. Now, there's another, and I think this is to do with the jump. I think that's to do with the jump. So I presume that is the same as these lot up here. Yeah, it is. Right, okay. So, has the user pressed jump and Wiele jump state is equal to jump off? Okay. Now the problem is that's handled. That's handled in the input, I think. Hang on. Right, load jump state, branch if not equal to 0. So if we're jumping, don't take any inputs. So where's the jump? Here we go. So we actually kick off. Jump state there. So how am I going to test motion? How am I going to do that? Because I've already set. Oh, it's force direction. But I can use Wille's direction for that. Hang on. Yeah, I can use Wille's direction for that. So we could do that test here. We could do that test here. So basically, all it's doing is saying load direction branch if equal to bypass. If it's equal to no. Yeah, if it's equal, then set for 2. There we go. So if it's not equal to 0, then we store direction into force direction. Jump to exit. So set for 2. So this is where we're going to load 2 and store it into. In fact, let's do that. Right, let's do this the other way around. So branch if not equal to Right. Load direction. If it's not equal to 0, then we want to store it in force direction. If it's equal to 0, load 2, and then that works. That works. Right. Okay, collision time. Collision time. Ugh. Right. So our test here is motion. Our test here is motion. So is it equal to 1? Then we're saying we're going to look right. All right. And if it's equal to -1, we're going to look left. Right. So are we moving? We've now detected, because we're using the variable motion to do that. And then we work out which column we're looking at, yeah? So depending where we are. So we look at the column that we're on is 0. If we're looking left, it's -1. If we're looking right, it's plus. Then this, I'm not sure about that. Right. Column. Branch if equal to... Oh, that's that, isn't it? Branch if equal. If it's... Remainder. We test when it's equal to 0. So that's this. And we know that works because the wall... We collide with the wall. We collide with the wall, don't we? And if we're in the middle of a jump,
the name of this part? Just don't let that creature see me in the darkness. There's a hallway there. I wonder if I can just run.
Night, Furling. Sorry, I missed him. See you later. Hey, sounds like Skim. Is that Skim? Welcome, mate. Welcome in. Oh. Right, we're back on collisions, mate. Back on collisions. Right, so I need that one. Where's that one? It's down here. Right, I've had enough. Right, I'm gonna get rid of all that because I'm starting again. Right, so this should still be working on the wall. So we should stop. And we don't. I've broken it. Ugh. I've broken it. What have I done? Load the motion. It's like it's not going in there. Motion's always going to be 0 though, isn't it? Oh, we test. Oh, it's direction, isn't it? It's direction. It's not motion, it's direction. Because motion's always going to be 0 because we reset it. But, oh no, but we don't, do we? Motion will always be 0. Hang on, let's put that back in. I want to do a test. Do we get in here? Do we get in here? We should get in here, surely.
Motion should be the direction you're going to move in this frame, isn't it?
Yeah. This is only set in. This is what I was. What if? Oh, hang on. If the motion is not equal to direction, oh, that's why we're going there. We should be going there. If the motion is not equal to the direction, we'll leave it all. So I think that's what was happening. Motion was not equal to direction. It was always zeroing it out. Right, let's try that. Let's try that. See if that stops me at the wall. Oh.
Well, you still got the red collision right, so.
Yeah.
And the collision flag was there to show that there was something in front.
Yeah. It does pause. It just pauses for a fraction and then carries on. Right. Oh, we're back to that again.
Is he stuck now?
Yeah. Oh, why is collision so difficult?
Right, so motion is the direction from the previous frame, motion is the direction from the new frame. But after you've made all your decisions, are you moving based on motion, moving the character based on motion or direction still?
I'm making the character moves on direction, not motion. Yeah. Because we are storing whatever's in motion here. Yeah?
All right, okay, yeah. So you're storing it into direction. It's just the way it pauses when you hit the wall going to the right. It's like, yes, I've realised you've stopped. Then I come round to the next frame and gone, oh, you can move again for some reason.
Yeah. And that's what's concerning me.
If it's moved on the next 2 pixels, it's not on an 8 pixel boundary, so it doesn't check then.
Yeah. So, hang on. So, direct... Oh, maybe it's... Have I... Hang on. So, if we've hit the wall, do I zero out the direction? Hang on. Oh, I zeroed out the input direction.
Yeah, and then when you come round again, you've pressed an input direction. It's different.
Yeah, so it's
Motion's
direction. Yeah.
direction.
Right. So let's do this. I've just noticed some things in there. Hang on. Let's do this properly. I've just noted a few things. Load 0, store 0. Let's get rid of that. Load 0, store 0. Get rid of that. Right, let's see. Let's see if that stops me. We're doing this one check at a time. Right. Are you kidding me? I promised I would not get angry. I promised I would not get angry. I promised I would not get angry.
If you get angry, I'm going to phone up Coventry Post Office and tell them to put a 2-day delay on your present.
It's yeah. Right, let me just check the execution. Load the direction. Okay, so we load the direction. And we're not doing anything else with it. Right. So why is that? Oh, you. Twonk.
What a plan.
Now the direction's not going through. That's strange because we're doing the check collision there, so it should be set in the direction. Collision. Where's the user input? That was working out motion, wasn't it? Go to direct. Right, load the user input. Store it in motion. I'm just wondering if I should take that code and put it in there as well. This bit here. Let's do that. Let's take that out of there. Take that out of there and we'll put it in here. Right, we'll put that there. So no more RTSs. We are going to call it update direction. So take that RTS out. Update direction. Is this the same as that? Then we need to go to update direction as well. Then we do all this Jiggery pokery, and then RTS at the end. Right, so that should be updating the direction. It works out whatever the motion is. Load the motion. If it's equal to 0, bypass it. So the direction should still be the same as the previous one. Compare it with the direction. If they are equal, then fine. Bypass. Alright. Right, mate. Oh, what's going on? Docster does not appear on the above credits. No, he's got his own, mate, because he's a co-producer, not a producer. And one of those producers will be going, unfortunately. A long time producer's is cancelled. Yeah, no, Docster, he went from assistant producer to co-producer, as you went from assistant producer to producer. So you're in the same rank as C64 Mark and all that, yeah. As Docster's in his own tier, he's the only one in that tier. Right. Let's see if that works or not, because I don't think it's going to work. No. I must... I can't be... I do it in check collisions, don't I? I don't jump out of check collision. I don't jump around it, do I? No. Work out motion. Right, I'm gonna... Right. I'm going to put a breakpoint here. If the input is different than forced, let's see what happens. Right, so it shouldn't move because input is 0, forced is 0. So if I go left, well, we're definitely going in. Okay, let's go through it. Load 0. It is equal. Load 1, store it in there, jump to there. Load 1. Compare with 2, branch if not equal. And it's... Oh, it stores 0 in motion, but we didn't update direction. We didn't update direction, but now it's going, it's saying there's an input all the time. Okay.
Yeah, that's the debugger. It don't like it.
No.
Because it doesn't update the keyboard status.
Yeah, but it didn't update. It didn't update direction. Hang on, let me just check what direction was. So direction is 09 ED, 09 ED, and I don't think it updated it. There. So this is where we're aiming for here. So load branch if equal, which it's not. Compare it with direction. Now direction 0, so it shouldn't branch. There we go. So it's not. Compare it with 2. It's not equal to 2. Have I got that? Have I got that wrong? I think I've got that wrong. I think that's the problem. Where are we? Here, right. Where motion is not equal to 2. When motion's not equal to 2. Oh, you dope. Right, that should be equals. If it's equal to 2, we 0 it. Yeah, if it's because the actual if is not equal to 2. If it's not equal to 2, set direction to equal to motion. So that's right. That's why. Okay. So now, let me take the breakpoint out. So now, hopefully, we're going to get Mr. Willie moving again. Come on, come on, come on. Stop! Finally. There we go. There we go. There we go. There we go. Oh! Stop! Hey, stop! Oh dear. Right, okay. We got a problem.
It looked like his hair was on fire.
His what?
His hair was on fire.
Yeah, is going without any input. Okay. So that test, that test is not quite working, is it?
Just call it AI driven.
That's this bit here, isn't it? If the input.
You can save that bit of code for the demo screens.
Yeah. So that if statement is slightly more complex than we actually thought. Okay, so if the input direction,
force direction should still be 0 at this point.
yeah,
Not-
so but input direction would be 0 as well. That's what's happening. So if input direction is 0 and force direction is 0, we're just updating the direction. So what I need to do is we need to put 0 into motion, don't we? Because technically we've stopped moving. Yeah, let me do that. Let me do that. So if input direction is equal to force direction, then that would be the motion anyway. Right, let's see if that let's see if that solves that. Ugh. Right, here we go. Let's just check that the wall still works. Yes, it does. Right. Now, so that isn't fixing it. If motion is 0, it bypasses it. Okay. I can't stop the direction, because if he's being forced to move, oh, that would be fine. All right, let me do this. I think we just need to stop the direction, because if the user input is 0 and the force direction is, say, -1, it will still go through the evaluator. But if the input direction is 0 and the force direction is 0, because there's no force being applied to him, we should kill the direction. But we don't do... Yes, we still do that. Yeah, okay, right. Let's try that. He's got to stop. He's got to stop. Right, walk. Okay, I think we've got it. I think we got it. He stopped. Right. Right. So.
I'll now try jumping.
Yeah. What I was going to do was I was going to change the collision highlighter. I was going to change the collision highlighter to. Yeah. I want the collision highlighter to only highlight the squares that we're looking at. So it's going to be based on it's going to be based on the direction. Right, where do I fire it up? Right, here we go. So this is clearing out. This is clearing out. So I don't need to look at that. I need to look at the where it sets it, which is not in there. Aha! Here. So that is going to be that one. Right. And then set that into previous. Right, now I need to go into the routine. I need to go into the routine because what I want to do now, I only want to show which cells it's going to be evaluating. So it's going to be based on direction. So we're only going to show the cells that we're going to look at. So where are we? Work out motion. So it's here, right? So we store away where he's going. No. Because we're going to be looking above. We're going to be looking above him +1. No. Let's put it back. Put that back. Put that back. And put that one back. Oh, that should be still right. No, we'll leave it as it is. I'm going to leave it as is because I want to see. So that should be still showing everything. The only difference is that the head and right, there we go. That's a good place. So the only difference is oh, what's going on there? Is above his head we're going to be testing 2 places. At the moment we're only testing 1. Yeah. So above his head we're going to be testing 2 places, and below him, as in underneath him, we will be testing only 2 places as well. Yeah. So we need to change. I need to change this to show the right positions that we're going to be testing. So let's get that right. So keep going, John. Keep going, John. Keep going. Keep going. Keep going. Work out. Here we go. So this is working out above his head. So we only do. We're only doing 1 above his head. When in fact we need to do another one. Oh, John, come on. Right. So this is directly above, and this one is directly above +1. So we're looking above and then in front. So that's going to change the way this works. So we increased the Y. And we need to do this twice. That should correct it for there. And then the lower, here we go. The lower should be, so there's 1, 2, 3. Right, so we don't do that one, I don't think. Right, so the bottom's wrong. Right, the bottom's wrong, top's right. So I want to put this back in. I want to put that back in. So that one is okay. It's this one that's wrong. Do that and get rid of that one. Right, let's try again. Right, that's better. So we're testing, and then it changes. Yeah. Yeah. Yeah, that's right. Right, okay, so we've got our highlighters right now. Here we go. Yeah, right. So our highlighters, right. So we've got the we've got this bit done. Right. So we've done all this bit. So we work out whether he's left or right. We work out whether he's crossing the boundary, so we can look one below him as well. We've done the dead. We know that we've done the dead because when he walks through the branch, you know, it goes red to signify dead. So
ever impressive.
The wall contains but never duplicated.
Warlock.
Morning, matey. How are you? Hope you got your drink. Morning, morning, morning. Right, so we're going to try and do the jumping. We're going to be doing the jumping. So we're going to try and do one at a time. We're going to try and do one at a time and try not to get in a mess like last time. So we've got our thing. So this is it. Jump, check while jumping. I think that's the one. Yeah, check while jumping. So the first thing first is we was checking for the wall, isn't it? So are we jumping? So that's the first thing we've got to check. We test. I think we don't test for jumping. We just test for are we moving. So we test that are we moving, and we go yes. If we're in the middle of a column, we don't bother checking, so we go to jumping. Now, is that right? Is that right? If we are in the middle of a column, do we check for jumping? Do we check for jumping? Yes. Sorry, I was looking at the picture on that. I've got the picture on that side, but this. So this is where we're going to be checking. Are we jumping up? Yeah. So are we jumping up? And if we're jumping up, are we going to hit the wall? So we fall back down, fall straight back down again. Yeah. But did you notice that we was falling down okay? Because before we didn't. So if I fall off the edge here, it falls down okay. Now, it didn't do that right last time, so yeah. Right. So check while jumping. So are we jumping up? So yes, we're jumping up. That's here. Look up. Get the top and to the right. Did we die? So maybe I need to do that first. Right. If we're jumping up, then that's probably the easiest one, isn't it? And then we can do it, because jump, then falling back, the arc is where we test for the floor. So let's test for... Did Spitz do the graphics? Yes, he did. In fact, he's updated them. Oh yeah. He's updated them. So he's been a busy boy, seeing as that he's got elections to run. Seeing as he's got elections to run. Yeah, he's been tweaking a couple of them. He's done the foot this time. But we've got him. We've got him moving. Got him moving. You've probably just seen level 1, look. But we've got the bad guys moving, look. So now we're trying to do the collision detections. So let's. So the problem that we had before was when we jumped. Hang on, let's get back here. So when we jumped, he was going through the wall, yeah. And we have a problem. Oh. Oh, hang on.
He's stuck in the wall now.
No, I think we're in twos. I think we're in twos. I think the force direction is 2.
Hello, John here. Thank you for following. Hope you enjoy the stream.
What was force direction? Who followed? Who followed? Toilet Twitch, say hello. Don't be afraid. We don't bite. Honest, we do not bite. We moan a lot, but we don't bite. Oh. I know what I was after, wasn't I? I was after the thingy. There we go. I don't want direction. I want forced direction. There it is. 09EE. 09EE. Right, 09EE. Memory, 09EE. Yeah, we're stuck in 2 land. We're stuck in 2 land. So that would be cancelled out on the jump finish. Mikroman's alright. What's two land? Well, I don't know what two land is. Right. So it's on the down cycle, I think. Of the jump cycle. Yeah, I've got. We've got a motion variable, but the standard three states, which is -1 goes that way, 0 stood still, 1 goes that way. But we've also got jump, which we've set to 2. But the problem is, in the jump cycle, we haven't got a reset for two land, because we haven't written it yet. So we're now when oh God, what am I doing? Go away. Yeah, we can't move. Fired up Visual Studio again. Just turn off. Shut down. Shut down. Thank you. So yeah, we're in two land. Because we've got a function that says if it's...
AndyMagicKnight asked me, Gordon, what is Tooland? Are you kidding me? Tooland sounds like something a toddler made up in their sleep. If you want to talk about real things, stick to the kitchen.
Oh dear. Right, so note to self, John, don't jump. Don't jump. Until we've put the code in, don't jump. Ah, dear. Do we put the code in for turning the jump off? I think we should. No, Matt. I don't think it does. I think the graphics engine's slightly different. The 6502 does the Mega 65 have the 65CO2 instruction set in it?
No, it's 45 GSO2.
All right, so it's slightly different.
Everything's completely different.
Right. Okay.
Of course, this will by magic work when John's finished it. There'll be 2 versions. It'll just recompile it for the 65. Just one might have my name on it. But no, they're completely different because of the Vera. The Vera is like a modern graphics card, whereas the way the graphics work on the Mega 65 is more akin to the Commodore 64. And there's no store zero function on the Mega 65 because store Z uses a Z register, whereas on the 65 CO2 STZ means store the number 0. So it's completely different. But at least it's not Z80.
That is true. That is true. I'm just wondering.
I think he's too tight to buy one, mate. You know, John, spend money. In the same sentence without the word not. I don't think you'll ever hear that.
Hey!
He'll get one from a cat boot sale in 30 years, I reckon.
Hey.
What? Am I wrong?
I might get one.
You might get one. When? When are you going to get one? Actually, you got to wait for the next batch now because I think they've sold out, so you're screwed anyway. But you're still too tight to buy one.
They weren't sold out the other day.
Are they? Okay. I thought they were.
Well, I had them all in my... I had it all in my basket, just didn't press buy. I was one click away from buying it. And then work got in the way.
I did that last time on Ferrari website.
Yeah, it's a great excuse, isn't it? But I nearly bought it. It was in my basket with all the bits, except for the bits you told me.
Why do you need one when you've got the emulator? Speaking of which, did you fix that joystick?
No, mate. I'm gonna. Like I say, I fell asleep before the stream.
No, I just wanted to play over the weekend.
Dude, I was gardening, mate. I had things. That's why you didn't hear much of me on Saturday.
Cool. That's all right. Just wanted you guys to. I didn't list on the Mac.
Also, I killed me roses.
What, did they melt in the sun?
No, mate. It was
big chocolatey mess.
I was absolutely fuming on Sunday. Absolutely fuming. I was really, really angry. I thought I put anti-pest rose anti-pest spray on it, and I didn't. I sprayed them with weed killer.
You garden like me. That's why I'm not allowed to garden. Literally, I'm not allowed to garden. So I can't even cut the grass straight.
So on Saturday, I thought I sprayed them with anti-aphid spray or whatever it is, rose spray and stuff like that. But no, I'd sprayed them with weed killer. So on Sunday, I looked outside and I thought, why is all my roses gone brown? Yeah. Killed them all.
Have you actually killed them or have you just killed the foliage?
No, I killed them, mate.
Yeah. Roses can be quite difficult to get rid of because I've been trying to get rid of one myself.
No, I've got rid of them. I've dug them up and everything. That's why I keep shuffling on my chair, because I've done my backing, I think. But when I cut them in hot, when I cut them to have a look in this, because my mum went and said, cut them and see if it's still green in the branch. Well, when I cut them, I had a core of brown.
Oh dear!
So it had actually gone down. So I dug them out, and I spent a fortune replacing them.
Yeah, they're not cheap, are they?
No. So yeah, I was absolutely fuming because the roses were put in when I bought the house. So this was going to be the 4th year, and hopefully it was going to be a nice, rose smelly thingy, and then I killed them with weed killer.
Stick to coding, mate.
Yeah, I was not best pleased. I was.
Yeah.
Yeah, I was.
Best not wash the car then, John.
Oh, I tell you, mate. I tell you.
You'll be getting the paint stripper out instead of the soap.
Dude.
What's sandpaper?
Dude, I mean, I was really pleased with what I was doing, and I was going, yeah, look at all the, because the garden's starting to look nice now and everything. And I looked at the roses and I went, oh, they're covered in these white things. Right, let's get that spray out. So it was purely my fault because the rose spray and the weed killer spray are both blue bottles. So I just grabbed a blue bottle and didn't bother looking at the label and just started spraying them.
Now that's interesting, because the stuff we've got, the good stuff's green and the bad stuff's red.
Yeah. Warlock. John in the garden, Control Z, Control Z. Yeah. I wish I could have done that, I tell you. But it was... Sunday morning I looked out and I went, why are my roses brown? And then I got out there and yeah.
Okay.
So I've replaced them. I've put new roses in. So yeah. So my green fingers are not so green anymore. Oh dear. Right. Okay. So I've put some of the code back in from the previous episode.
Wait, I just realised something.
What?
Right? You could use the bug spray in your code and fix it.
Yeah, I suppose. So I've put a bit of the code back in, right?
Yeah, but Andy, do you spray it at the keyboard or the screen?
Oh, I don't know, mate. I don't know. Right, let's put the whole lot back in. I've decided I'm putting the whole lot back in. Right. Right, let's see what damage we've done. Does it stop it jumping? Right. Now I know if I jump it's gonna go into land. To land. But let's see. Does it stop it jumping? Yes, it does. But I'm still in land. So I need to, when we're out of the jump, I need to cancel land. Is this it? Jump down. Oh, hang on. Got to put some code in. Put some comments in here. Set it back to 0 after 2 lands. Yeah, the thing is, I think it's in the execution. I might have to put it in the execution. Hang on. Do I? So this is jump up. Right. Jump up, execute, jump down. So this is jump down. Load the jump height. Not negative. Here. It's here. But I'm not sure. Because we need to put the test for falling too far. Load jump height. But I suppose that doesn't need to, does it? Hang on, let me just put this back to so store 0 in storage dot Wiele. Oh dear. I know you're still there, you stupid thing. that was the ticker playing up then. Oh, it's force direction, isn't it? Right. Right, let's jump. There we go. No longer in two land. I am not sure about that. Right, okay. All right, okay. So this is a new problem for us. So this is a new problem for us. Build, save it, build it, ship it. Yeah, but this is a new problem that it's not. It's when it jumps, it's just jumping straight up. Oh, it is playing up now. How did I get it walking? Right. Right, so it's stuck there. F12. Memory 09EE. Was it 09EE? Forced. Here we go. Yeah, 09EE. So it is. So 09EE is 1. But it's not taking my input. But it does allow me to jump, and then that's got to be right, but it's just jumping straight up. Right, hang on. The stuff that I've just put in, I'm going to take back out again. Hang on. Because it was doing it okay before, wasn't it? Hang on. Check collision. Ah, here. Right. Let's just rem this out. Right. Right, so if I... No, it was doing it beforehand as well. Okay. Right, so why would that be happening? Why would that be happening? Is that to do with the motion, that whole thing that we was talking about earlier? Um. I just don't get it. I just don't get it. Why is this so frigging difficult?
That's the wrong question. The right question is, why are you making this so difficult?
Well, the whole point of that thing, it was because of the landing on the conveyor belt. I think I know. I think I know what is causing it, but I don't know. Am I going in the right direction? No, I'm not. I think it's here. So we load force direction, which is 2, then we reset them. So reset. Oh, hang on. Oh, that's the issue. If force direction 0. Sorry, force direction is 2, then motion is 0. But then this is supposed to take. This is supposed to.
Hold on, Johnny.
Hey?
You store A in Willy motion, then you store Z in it straight afterwards. Don't you need to branch over that?
Yeah, that's what I was looking at. I was thinking. And that's what I'm saying. It was storing 0 in motion straight away. That's why I was just looking at it. I was thinking I'm supposed to. I've got to jump here. Oh, I suppose I could use that there as well, couldn't I? And there. Right, let's try this again. Right, can I run and jump? Oh, you're joking. What am I doing fundamentally wrong?
You know when you're jumping, you set force direction to 2 to say you're jumping.
Yeah.
But how do you know which way it's jumping, left or right? Or straight up and down? that must be a different variable. Which one tells it which way you're jumping?
It was direction.
But you've reused direction to do it differently now.
I know, that's why I'm looking at this, because we set direction here. I think that setting up motion is not as it is. There's other instances where it doesn't get updated, I'm sure, not just that one that we got down to. Because direction, I'm just, it was working before. Why is it not working now? I think there's another test in here that we've misunderstood this if statement. If force direction is not equal to 2, that is, I think, the problem, because this would go through if force direction is equal to 2. Because I'm storing 0 there. I bet it's that there. I bet it's that. It is. Right, so it's that. If the force direction is equal to 2, we need to leave the direction as it is. So we just need to do that, I think. I think that's the problem. Does it stop? No, it doesn't. Oh, come on. load force direction, if it's equal to 2. No, I don't want it to do that. If it's not equal to 2. But if it's equal to 2, I want it to return out. Right, so I've stopped Wiele wandering off on his own. Right, here we go. Here comes a jump.
Good night, Mikroman. I'm not too late.
You don't want your Wiele wandering off on its own. No, mate. No, mate. No. I don't change force direction. But that resets them up. But I'm not going there. If force direction is equal to 2, I'm just returning out. That. So direction should be right. Direction should still be intact. It's not going in there, it's not even breaking. Oh, it's not going in there. We definitely store 2 in. We definitely store 2, don't we? In force direction. Do we still? I'm sure we do. Right, that's the execution. Hang on, input. Here we go. Load 2 into force direction. Okay.
Oh, I'm going to call it a night, chaps.
All right, mate.
We'll catch you on Wednesday.
Yeah.
See you later. Night.
So load direction. If it's not equal to 0. Set the force direction, which is the direction it's going. But if the direction is 0, if the direction is, that's why. I'm not sure I need this. I'm not sure I need that. Right. I think we've got it right now. So it's remembering which direction it's going when walking when I let go of when I let go of the control. Right, does it? He still jumps vertically. Right, I think, and it's also stopping. Look, it's also stopping when he hits the wall. Right. So I think that was the problem here. For some reason we was loaded in direction, and if the direction was 0, we was setting it to 2, but only when we wasn't pressing a key. So basically it was only doing it when Wiele was stood still. So we'll do that and get rid of that. So hopefully now, so we're still going red when we hit the branch. We're still stopping at the wall. See, it's right. That's because we're not. But he's still stopping at the wall when he's jumping. So that's a good thing. Right. So now we need to put the code back in where he's. Let's see. Right. Right, so that's where check if he's walking on any of the things, then he's not crossing the page, he's not crossing the Y boundary, so that means we're not jumping. So if we're jumping up, check while jumping, so that's this one here. So if he's jumping up, then we're going to look above him. We're going to look above him. So the question is, yeah, so we're going to look above him, and then we're going to look in front of him. So they're the two squares, so directly above him and in front of him, which matches our collision. So we're just putting it all in one, right? So this right. So load the collision. Is it the wall? If it is a wall, then we don't need to do that. But we need to turn off jump state. And then put him into falling state. Right. Right, let's try that. Does he now hit his head on the wall? Right, let's do this one first. Right, so he hit his head on the wall, yeah? He hit his head on the wall. But we haven't got the jump down tests in, so that's why that happened. So let's put the jump down test to find the floor. So that's that. So So what we're doing is we're checking with jumping. Are we halfway between rows? If we are, then we check for the jump state. Are we jumping up? No. Check what? See that? Check while jumping. I need to change that.
Himself in a predicament most dire. In the labyrinthine tunnels of the mine, where danger lurks around every corner and treasures glimmer in the darkness, our intrepid adventurer is trapped. The code, the very fabric of his world, is malfunctioning, causing chaos in the subterranean landscape.
Oh dear. Right. Right, so compare with jump up. If it's not equal, check while jumping. Now I need to say check while. Let's change that to while jumping down, so we know what it means. Have I got check while jumping there? Yeah. Check while jumping down. Right, so that's jumping down. So we need to check the bottom. So on the down scope, we need to check certain parts of is underneath. But the problem is we need to check both. Yeah. So where's that? Go to that. Go to definition. Here we go. So we need to check bottom left and check bottom right. And the reason why we need to split them is because of the collapsing bit. Because we can collapse one or both. So we could walk onto and only one collapses. And then when he walks again, it's always two. No matter what, it's always two. So so we need to do left and right. So let's do this. And we do increase X, which will be then right. So we do left and then do right. But I think uh, 0, 1, 2. Yeah, so that could be right. So and then we need to check for the floor. This is the floor check here. But first things first, we need, because we've got bottom right in the accumulator, we'll OR it with collision bottom left and store it in collision bottom. Oh, have I got a collision bottom? No, I haven't. Collision bottom. There we go. So the collision bottom is the combination of left and right, because it doesn't matter which one it is. We're just testing the floor. Yeah. Right. Let's see if we stop. Let's see if we stop. What's going on here? Check while jumping. Oh, we changed that, didn't we? Check while jumping down. Right. Okay, let's try again. Oh, it's just too far. Oh, he's falling just too far. It's falling just too far. So it's the falling that's the problem, and I think it was 2 pixels too low. Yeah, 2 pixels too low. Why would that be? Is my check wrong? Oh, should I be checking when the row remainder is... That's jump if not equals. So it is... Oh, okay. But he's not doing that. He's falling, isn't he? He's falling. So it's here. We're not testing for the floor when we're falling. So we need to test for the floor when he's falling. So how can I put that into here? Right, okay. Check.
You need to do it. Can you do it in your collision detection? Or because he's fallen, it's not doing it?
It's not doing it when he's falling, because we're checking just for the jump state. I think here we need to check for the fall state as well, so it checks for the floor. But it needs to be here on the down slope. Right, so check under Willie's feet. So I'm not going to jump to not jumping. What I'm going to do is I'm going to go, if it's equal, then go to check under Willie's feet. Then if it's not equal to, then I'm going to check the full Willie's full state. Compare it with state falling. Then we're going to do jump if not equal to jumping. So here then we work out underneath him, and then we can test for the floor. So colliding with the floor. Right, so here we need to reset the falling state and the jumping state. Right. So let's go up here. So we have a floor, so that's here. So the jump state is off. And also we need to turn the full state off as well. Not falling. The problem is, here we're going to have to check for the... But I'm sure I did that here, didn't I? No, I didn't. We didn't check for full height. We didn't check for full height. So that's what we need to do, is check for full height, and then he dies. Right, load collision bottom, and it with the floor. Branch if not equal, we have a floor. Right, okay. Right, let's see. Ooh, is it not full state? Four, 5, 2. 4, 5, 2. Oh. Okay. Let's do our test. Right, so jump. Oh, he's still 2 pixels too low. And he's falling. Oh, he's landed on it. Now he's 2. Now he's 4. Now he's landed on it. And we're back into Willie being 2 pixels too far. Whoa, 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 stop, 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 stop. 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 Oh no. Oh, stop. Stop. Oh, he's still in 2. You forgot the rules of 2 land, yeah. But it could be me as well. It could be me. It could be me, because it could be because of this here. Because we wouldn't be going through this if he's hitting the floor. Let's see if it's because of that. Now falling's not working. And I can't do anything. Oh.
Everyone's a wally. A nincompoop, a noddy or a nerd. Everyone's a wally. Everyone's a wally, that's the word.
There's been clever, and there's been a pain up the backside. Oh, I don't know what I've done, but I've done something. He's not falling now. He's not falling now. Yeah. I'm wondering if it's this. I'm wondering if it's that, and I'm gonna have to do it on the up, aren't I? To make sure. Yeah. Hang on, let's make sure I'm doing it on the up. Yeah, that's the up there. Right, let's try that again. Right, that indicator's not right either. Yeah, I think that indicator's not right now, because I think I've got it to switch. So when we turn round, I think, yeah, I think I know what the problem was. Now there he should be falling. There he should be falling, but it is not. But as soon as I hit a key, he falls. He's still thinking I'm on the floor. Yeah, he's definitely thinking I'm still on the floor. Oh. Anyway, so we've got him landing on the thing. Let's see. Oh, he's still going below. He's still going below. Well.
Oh, that's nice. So when he hits his head, you stop the up and do the down, but the thing is he's not at the peak of his up, so you don't need to do all the down.
Yeah. But this...
That's a different thing.
Yeah. I wonder if he's on the boundary there. I wonder if he was on the boundary there. Well, that's annoying. I take my finger off the direction, it's still going in that. There's a delay. And I take my finger off. Oh. That's not a good one, is it? So he's falling through the floor. So that means the Y must be an odd value, because it's never doing any collision detection. because it would never get to 0. I bet that's an odd value on the Y. See, he's back on there because he's done his full jump cycle, isn't he? Oh. Why is this so frigging...
Have we actually gone backwards this week?
Say again?
Have we actually gone backwards?
No, we've gone forwards, mate, because we're doing the proper checks on the floors and everything, as before we weren't. Yeah, before it was just jumping in any old, even in mid-air, it was jumping on mid-air. So we have gone forward, it's just that we're like there. It's gone 2 pixels too far down. Can you? I don't know if you can see it.
Yeah, I can see it.
So I think it's because we're only checking on the boundaries of the cells, yeah. So, and I think what's happening is that it's just like with the jump, like it's gone down another 2 pixels. But if I hit jump now, it's going to do the full jump cycle, and then it's back on the floor, look. But when you jump...
I see what it's doing. If you detect something hitting his head, you're flipping the directions. He's going to the full state or the jump down state, not the full state.
No, he's going to the full state. Do you think I should make it go into the jump down state?
That's what I've done.
Okay, let's try.
Yeah, she's going to full state because you stop forward motion if he hits his head, don't you?
Yeah.
You're both right, but the issue you've got is that shouldn't count towards the full death height.
Okay.
I believe.
Okay, let me change.
This is why I've done it that way.
Hang on, let me just change it then to go
and
down.
I also cleared the flags for forward motion as well.
Low collision top, check with the wall, state not falling. Right, so put him into down and not falling, okay. Right, so I'll put him into jump down state. So it's not falling now. Here we go. No, he's still below.
I also moved it on a jump position so it doesn't fall as far.
Okay, that's what I was just about to check. I
either move it forward one or back one.
That's what I'm just about to check. I got a sneaky suspicion that it's done the jump and increased the jump height, but maybe I need to decrease this jump height in the collision, and that's why it's falling one too far. Like you said, you advanced it on, didn't you?
Yeah, I had the same problem. That's why I got around it.
Right, so let me do this. So if instead of increasing it, I decrease it to bring it back down in line. I wonder if that fixes it. Still doesn't fix the fact that it falls through the world, but I think that's a different problem. Right, so here we go. Oh, Andy, you're a star. Look at that.
Well, technically I cheated because I fixed mine at the weekend. Does it work when he's moving forward though in an arc?
Yeah, we've got a problem with the wall though still, but I don't think I've tested the wall yet.
It doesn't matter if you need to. As soon as it hits his head on the top, you need to clear your direction counter so it falls vertically down.
Is that what happens in reality?
Yeah. Yeah.
Hang on.
So it's like Darcy said, he goes into the fall state, but the problem is that fall state doesn't include or doesn't increase the death counter when he falls.
Right, so I'm going to jump. Oh, so he does. So he just goes straight down. Okay.
Yeah. So all I did was clear the two flags I've got. Moving left, moving right.
Yeah. Okay. So that means that here here we need to no. Right, let's try that. Right, here we go. Hit your head. There we go. That's what you think? Yeah?
That's looked right to me, mate.
Right. Oh my god. We're getting somewhere. Oh, that's unfortunate. So he's doing the jump there, right? But as soon as I get... Oh, he's dropping down too early. Oh, that was okay. There. Okay. Oh. So we've still got to work out these tests.
I refer you to my collision matrix thing that I did.
Yeah, I'll have a look, mate. I'll have a look.
Because basically it detects all your points around him, and then you can just look up in a table, you know, what he's actually hit, rather than keeping testing things.
Yeah, I was because that's what I did in Hunchback. That's what I did in Hunchback, was have that thing, but I don't know why it's jumping there when it's It's detecting something.
I think it's because it's a pixel too far, and because it's a 16 pixel 16 pixel wide sprite. It's detecting the right hand side of him as hitting that brick, even though he actually hasn't.
Oh, I see. Oh, I see what you mean.
I think that's why the original graphics don't give you that problem, because he can't be in the offset at the time, and that's how he's built the levels. So
Right.
that they're always on two boundaries, and they're always, you know, if you look at the positioning stuff, it's very restrictive. But it's just done a really good job with it.
Yeah. So he does jump above. He does jump above there. He does jump above it. So we're jumping above it fine.
The height and everything's fine, mate. The whole movement of him's fine. It's just your detection's off, because you're doing the graphics slightly different.
See, he's not banging his head there. Even though it should be testing it. Not there. Now it is. I'm wondering if I'm not looking in the right place.
Are you just looking at the one above the left-hand side of him, and not the right-hand side of him?
Well, this is why I'm testing all the other places.
Because I'm testing two parts of the matrix. The two top middle.
Collision. Is he actually only colliding when he's directly in line with the brick?
That's what I'm testing for, mate. That's what I'm testing for. It looks like, yeah, it's directly below. Whoops, and that was the thing that I was getting annoyed about.
I think you only detect it on his left side, not his right side.
Yeah.
I'm going to have to leave you to it, John. I've got a meeting first thing in the morning.
I know, mate. I've just noticed the time. I've just noticed the time as well. All right, mate. Thanks for being there. Right.
No problem. See you all Wednesday.
Yeah,
Night, guys.
see you Wednesday. Yeah.
Nice, awesome.
So I'm just so I'm testing.
I'm currently unemployed, so I can stay all night.
So that, if he's pointing, that would be pointing forward. That would be pointing forward. Right, I think it's that. I think it's these that I've just put in. I'll put it somewhere else as well, didn't I? Hang on. That was the up. Where's the down? Cool, that airplane's a bit low. Right, that's the down. Yeah, that would be wrong as well. Right, let me put these back to what they were. I think doing that has screwed me over a little bit. Oh, I did that because of it wouldn't fall off the floor. Oh, we're back there. Right, so does he jump there? No. See, that's right now. Let's move him away. He's alright there. Alright there. Alright there. Alright there. Yeah, that's where he's just hitting the wall now. Right, what about there? That's fine. But he doesn't fall off the floor now. He stops. Ugh. All right then. I'm calling it there before I get annoyed. The problem was with Hunchback, I detected all around him and then do what you've done, but I had loads of problems with that. The way I did that way. That's why I was trying to do it differently.
There's a million ways to skin a cat, mate.
Yeah, I think I'm gonna have to. I think part of the problem is that my jump detections in the execution and the collision detections in a different part as well. Maybe I've not got enough flags in operation. But that is I think the reason why this is not working is because it's still detecting this floor. Well, yeah. It's actually, I think it's in a state of falling but not falling.
It's like the way the original graphics are done is based around how all the maps work, and
yeah.
So he would have a foot still on there.
Yeah.
Because it's position on the screen, or the remainder being divided by 8 determines what frame you're going to use. So it's balanced so that it will always have a foot, or it'll look like he's got a foot on the edge. So and all the jumps are kind of timed or enough distance to get between them.
Yeah. All right then. All right, we'll carry this on Wednesday, and I'll have a look at your code, mate.
Yeah, I'll push it in the morning because it's a bit out of date. Stuff I did over the weekend's not been pushed yet, but I'll.
All right then. All right, guys. Well, thank you very much for joining me. We've made some progress, but we've got some other issues now. Alright then. Well, thanks a lot, guys. And I will see you on Wednesday. Alright?
Bye, mate.
Take care.
Bye.
Bye.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Warlock.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Dude, you didn't have to do that, mate.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh my god, more bits? Thank you very much. You guys really spoil me. Oh no, here we go.
Hi, John here. Another subscriber. Stay a while.
Thank you, D4,
Stay
for the bits,
forever.
mate. Thank you. I'll let this run through.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Right then. Thank you very much for those gifts. Thank you, Warlock, for the gift subs, and thank you, D4, for the bits. Much appreciated. Alright then, guys. I'll see you Wednesday. Alright? Take care. See you later. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.